Let's take a look at some applications of quadratic functions. So in particular, we want to look at some optimization problems. So optimization problems in general are problems where you're looking for a minimum or a maximum of something. And remember, a minimum or a maximum is basically finding the vertex point of your formula. So first we need to create a formula and then consider the minimum. So what is the minimum product? So that's telling you how to create the formula of two numbers whose difference is 6. So two numbers whose difference is 6. So that would say that one is x and one is x minus 6. So if we multiply those numbers, so it's like our f of x is now x times x minus 6. That gives us x squared minus 6x. So now if we could find the vertex of that, then we would know where the minimum is. And there's a minimum because it's a parabola that's facing up and it has a minimum vertex. So let's find the x value. You could either complete the square quite easily here, or you can say negative b over 2a. That's a 6, negative 6. So that'll be positive 6 over 2, which is 3. And if we plug in a 3, we get 3 squared minus 6 times 3, which is 9 minus 18, which is negative 9. So the smallest product of two numbers that differs by 6. Now you have to decide, are we looking at the 3 or the negative 9 based on the question? Well, what this tells us is that the vertex is here, and this is all the numbers. Now, what does the x mean? What does the y mean? The x was one of the numbers, and the y was the product. So because they're asking for the minimum product, they're asking for the y. So negative 9 is the minimum product. Let's try another example. Here, a rancher needs to enclose two adjacent rectangular corrals, one for sheep and one for cattle. A river forms one side of the corrals and 180 yards of fencing is available. What is the largest total area that can be enclosed? So we have a river, and he wants to have two rectangles like that, one for sheep, one for cattle. So now remember, it doesn't really matter how big this one is because this could move here and there, but we also have a constraint. We only have 180 yards of fencing, but he wants the biggest area possible, so that's a maximum. So, maximum area. Since we're maximizing area, our function answer will be area, whereas the input could be something like, say, for example, the width of the fencing. So if we know that x is the width, and we know that we have 180 total yards of fencing, well, let's take a look. We'll have 3x that need to form the width, but then we also have this other amount. So what do we call that other amount? So it'll be, say, plus y. So y will equal 180 minus 3x. So now we have our length, our width of x, and our length of 180, take away 3x because of the other three sides. This other side is a river, so we don't need to worry about it. The cattle are not supposed to cross the river. So when you have the area, you have length times width. So let's go width times length, x times 180 minus 3x. And we now have an area formula. If we maximize this, meaning we figure out what the top vertex point is, the answer, because they're asking for the area, will be the maximum area. So that's 180x minus 3x squared. You could rewrite that as negative 3x squared plus 180x plus 0 if you want to make it an ABC format. So you can see that it is a downward facing narrow parabola. So there is a top point at which the area is maximized. And we need to figure out what that top point is. Now we can either complete the square, or we can know that the maximum x value will be negative b over 2a. So that's negative 180 over negative 6, which gives us 30. So the maximum width will be 30, but we now need to plug it back in to find the maximum area. So 180 times 30 minus 3 times 30 squared. You can plug it into either of those. And that gives us 2,700. And that'll be square yards of fencing. So make sure you understand what each part means when you create it. Label it. This is the width, this is the length, this is the area. Let's look at one more here. For a trip to a resort, a charter bus company charges a fare of $48 per person plus $2 per person for each unsold seat on the bus. If the bus has 42 seats, find the number of unsold seats. That produces the maximum revenue and the maximum revenue. That's not written correctly. Produces the maximum revenue, obviously. So we want to maximize revenue, so our f of x is going to be revenue. We know there are 42 seats, but we also know that the number of people will not be necessarily always 42. So what is our x? Find the number of unsold seats that produces the maximum revenue. So we could let x be the number of unsold seats. So for the revenue, you're going to take the number of people times the price per person. Right? So we need to figure out how to represent both of those things based on the information we have. Normally, the price would be $48 per person, but that depends on the number of unsold seats. So if there's X unsold seats, then that would be $48 plus 2 times the number of unsold seats. That would be the price per person. The number of people, however, is 42. Take away the number of seats that were not filled. And now we have an equation that we can continue with. So 42 times 48, 2016. We're just distributing this, plus 84x minus 48x minus 2x squared. So we're going to rewrite this minus 2x squared. Notice it's facing down, meaning we will have a maximum. That's good. 84 minus 48 gives us 36x plus 2016. So all we need to find now is our y value of our maximum, because that will give us the revenue of the maximum. However, well, let's start with the x value because we know that that's negative b over 2a over 2a, b 36, a negative 2, that's negative 36 over negative 4, which is 9. So if we input 9, 9 is the maximum number of unsold seats. That produces the maximum revenue. So if they asked us for the maximum unsold seats, that would be 9. Nine unsold seats would result in max revenue of, and we need to figure out how much that would be. Well, it'd be 42 minus 9 times 48 plus 2 times 9. So 42 minus 9 times 48 plus 2 times 9 gives us $2,178 of revenue.